Hello everyone, hope you are doing well. Welcome to the channel Master the Codes. And today we are going to solve a question related to graphs, data structure, and all those who want to check out more such content related to graphs data structure, they can go to the playlist. I have given the link of the playlist and added the card in the top right section of the screen right now. And also please like, share, subscribe to the channel to stay notified about the upcoming videos and content. With the, today's question has been asked by many companies and is usually the first question in their follow-up interviews. Like they ask a particular question and then they ask a more optimized approach of it. So this particular question has been asked several times. Without wasting further time, let us get started. Okay, so this is the question for today. It has been asked in Intel, Infosys, and many other companies. If you wish, you can try to solve the question on your own or wait for a few seconds and we all together will start solving this question from start to finish and explaining each and every topic or each and every intuition stepwise in a proper fashion. Okay, so now let us understand the question first, like what the question is exactly asking. We will go through the question line by line and look out for any information that we can find in a line and note it down. Right, so we begin. And in summer information school, if a student doesn't behave well, teachers make a hole in his badge. Okay, and today one of the teachers caught a group of n students. This is an important thing, you can look over here. A group of n students doing yet another trick. So in the first statement, what we have n students provided. Okay, right, and n. Now we don't know yet this n can be edges or this n can be vertices as well. That we will get to know when we explore the question further. Right, then let's assume all these students are numbered from 1 to n. Now when you look at this particular point, you directly get to know that the students are vertices. Right, from 1 to n there are n students and the labeling. Now this 1 means the indexing is starting from 1. The indexing is starting from 1, right? The teacher came to a student A and put a hole in his badge. But what happens? The student, however, claimed that the main culprit is some other student P of A. Okay, let's first understand it. We have a group of 1 to n students, like 1, 2, 3 up till n, and the teacher, let's say T, reaches a student, let's say 1, and puts a hole in his badge. Okay, now the student has a hole in his badge, but when the hole is put in the student claims that the main person was someone else. It can be 2, it can be 3, or it can be n. Right, now what happens? After that, the teacher come to the student PA and make a hole in his badge as well. The student in reply said that the main culprit was student P of PA. So you can say, like, if a student A asked the teacher to go to PA, then PA asked the teacher to go to P of PA, and then so on and so forth. This chain will continue about k times. Right, so it is a chain reaction, or you can say like a chain procedure, and this process went for a while. But since the number of students were finite, eventually the teacher came to the student who already had a hole in his badge. Now this particular thing is a bit important and interesting. Like, you can have a look over here. If I have a student 1, it said student 2 was the main culprit, then it says student 3 was the main culprit, and it says student 4 was the main culprit, and let's say the number of students are 4. Then at some point the student will say the student 1 was culprit. So what you can see over here, we have found a cycle. Right, we have found a cycle. So that is what you get from this particular statement. After that, the teacher puts a second hole in the student's badge and decided that he is done with this process and went to sauna. Sauna is some other person, so it doesn't mean much information in the question, but the only thing here is that the process ends. The process ends. Now, you don't know the first student who was caught by the teacher. However, you know all the numbers P of I. You know these numbers. Now, what these numbers signify? The P of I signifies the next student which is chained or which is attached to the current student. If the current student is I, then the next student is P of I, then P of I, and then so on and so forth. So actually you are given the chain of students, but you don't know which was the first student who started it. Okay, now what the question is asking from us. Your task is to find out for every student A who would be the student with 2 holes in the badge if the first student caught was A. Okay. Now let's take this example itself. If I say this first student, the reaction started with the student 1. Okay, let's say A was the student 1, then teacher went to 2, then 3, then 4, and then again came to A, reached A. Since A was already had a hole in his batch, the teacher put a second hole. Teacher put a second hole in his batch. So A was the person at which the process ends. The process ends. But if I take the same chain of events, and the process starts at 2, right, then 2 is marked first time, 3 is marked first time, 4 is marked first time, 1 is marked first time, and then when the teacher will come at 2 again, the process will end. So in first case, the process ended at student 1, and in second case the process ended at student 2, right? So that is what the question wants us to evaluate. For every student 1 to n, we need to find the student at which the process ends. At which the process ends. Okay, so now let us look at the constraints of the question. What is given? The first line of the input contains only integer n. That is, we have a single integer n, the number of naughty students, and the second line contains n integers, or this is the chain that we are given, where P of I indicates the student who was reported to the teacher by student I. Now this is the main thing that you want to take care, that I'll explain you. Let's take an example, the test case itself, and then it will be much clearer. Given the test case is this, right? Given this is the test case, 3 2 3 2. It is 3, 2, 3 and 2. Now what does the first line indicate according to the question? The number of students, that is n, right? Or this implies the number of vertices or the number of nodes. Then what does this line represent? For every student I, it marks the P of I. Now what does that mean? Just give a 1 based indexing to every student, to every integer in the array. Now what does this mean? 1 is marked with 2, right? If teacher comes to 1, 1 will say 2 is the culprit. And if teacher comes to 2, 2 will say 3 is the culprit. And if teacher comes to 3, 3 will say 2 is the culprit. So 1 will point to 2, 2 will point to 3, and 3 will again point to 2. That is, this particular line will give us the graph where every index is the first student or the first node in an edge, and P of I, that is the number provided, is the second node of the edge. Now coming to the constraints. The value of n is provided between 1 to 1000, and the P of I also ranges between 1 to n. So it means n lies between 1 to 1000, or rather n is less than 10 to the power 3, and similarly P is less than 10 to the power 3. Right, these are the constraints in the question. Now the main thing comes, like how to develop the intuition, like what all things we should ask when we are solving this question. The first thing is what type of graph this is, whether it is a directed graph or an undirected graph or some other type, and will it contain a cycle. Now this is the main thing, because if you look at the first point, you have found cycles, right? You have found cycles over here, you have found a cycle over here, and if you look at this as well, you have also find a cycle over here. So will it contain a cycle? Now the answer is yes, it will always contain a cycle. And what type of graph it is? It is a directed graph. Why? Because if you look at the test cases that is given, 3, 2, 3 and 2, and if you draw the graph, 1 is connected to 2, 2 is connected to 3, and 3 is connected to 2, right? So it is a directed graph, because from 1 you can go to 2, right? From 1 you can go to 2, but from 2 you cannot backtrack to 1. That is not possible. So it is a directed graph that will always contain a cycle. Now why it will always contain a cycle? Because let's say if the graph does not contain a cycle and the teacher T comes, it will mark a hole in the badge of the first student, then it will mark a hole in the badge of the second student, and it will mark the hole in the badge of the third student. And it will, where it will go, because for the graph for the condition to end, for the question to end, there is a student should get 2 holes in the badge, should get 2 holes in the badge. And now, since there is nothing left to check, we have reached the end, this test case is not valid. Thus, we will always have a cycle. At least one cycle, but we will have a cycle. Now, how will the brute force approach work? Let's look at this example. First is what all things we will need, right? What all things we will need. We are given the value of n, right? And we want to maintain the status of students that are marked. Right? The status of students that are marked. Now, how will you ensure it? You can use an array in that case of size n plus 1. Use an array of size n plus 1 because array starts with 0th indexing. So you have to create one extra element to apply the brute force method. Now, you want to check for every student, right? You want to check for every student. Let's start with student 1. In that particular case, what you have to do is you have to mark student 1 as true. Then you will apply either BFS or DFS and move to student 2. Then you will apply the same logic and move to student 3. And when you have reached 3, you will move to student 2 again. Now, when you have moved to student 2 again, you have found that student 2 is already marked. You will just mark it again or do nothing and simply exit and print the number 2. Right? And print the number 2. Now, let's see what will happen if I start from student 2. I'll quickly create the array, assign the indexing. Now I'm starting with student 2, applying a BFS or a DFS. I'll reach student 3, mark as true, and when I'll reach student 2, it is true again. I'll exit the loop and return 2 as the answer. Now, coming to student 3. I'll create the array again. You have to create the array again and again. That is one thing you have to do in brute force because you do not have any other option. You cannot use the previous array. You cannot use this array for the next test case. You cannot do this, right? You cannot use this array or you cannot use this array. You have to create another array for every time you traverse a new student. Now I'm at student 3. I'll mark 3 as true. I'll go to student 2. I'll mark 2 as true. And when I'm coming to student 3, 3 is already visited. So I'll exit the code and return 3 as the answer. So if you look at it, our output would be 2, 2, and 3. This would be the output, where in between you have to give extra white spaces. Now if you look at it, this is the required output for you, 2, 2, and 3. So now the next thing, since I am traversing, I am doing the traversal You can clearly see over here, I'm reaching from node 1 to node 2 or 2 to node 3 and 3 to again node 2. Which algorithm will work? Whether BFS will work or DFS will work. Of course, both will work, but which one is better? If you guess, then it is alright. Otherwise, I'll tell you DFS is better. Why? Now, the reason DFS is better because of this sentence. After that, the teacher come to student PA. Now, if you read the question again thoroughly, you will not find that a student, any student, is giving or rather claiming more than one student as the culprit. Right? It is not claiming more than one student. If I draw it in terms of graph, a scenario like this is never happening. This type of scenario is never happening. It is never saying both 2 and 3 are culprit. It is always saying that anyone else is the culprit, but I am not. But it is only one person. It is not more than one person. So DFS is much better since you can use the recursion technique very quickly. Now, the main thing is, can I perform any further optimization or is it even required? Now, if you look, the test cases given were less than 10 to the power 3, right? And what you are doing, you are running for every student A, right? You're running for every student A, that is can be maximum size of 10 to the power 3, and for every A, you are checking the graph. You are checking the graph, and when you are checking the graph, it can span to 10 to the power 3. So overall, the time complexity will be 10 to the power 3 into 10 to the power 3, that is 10 to the power 6. You will get order of 10 to the power 6 or order of n square, because n ranges from 10 to the power 3, right? N ranges from 10 to the power 3, so that is why you are going to get order of n square. Now, what about space? You are creating one array of size n plus 1, right? You are creating one array of size n plus 1, and you are using that array only once. You are using it only once. That is, you are creating an array for student 1, then you are creating another array for student 2, and so on and so forth up till student n, right? That means overall you are using n plus 1 size array n times. That is giving the space complexity of n square, and this is the time complexity of order of n square. Since they both are within the range, they are less than 10 to the power 9 or they are within 10 to the power 8, then you don't need to optimize it further. But if let's say you wanted to optimize, then you can use it a set, right? You do not need to create n arrays. You can simply use a set and repeat the operations on the set again and again. Repeat the operations on the set again and again. I'll leave the optimization to you. If you wish, you can try using this set as well. Otherwise, this particular way will also work fine by creating n plus 1 arrays, or rather n arrays of size n plus 1. So this is it for the explanation of the question. Now we'll move to the coding part. But before that, please do not forget to like, share, subscribe to the channel and hit the bell icon for more notifications. So here is the question. Mm, mm, mm. This is the link. I'll share it down with you in the description. Now, starting with, I have n nodes. I create the adjacency list, right? Using the scanner for the input classes. Then I'm taking the number of nodes as the input, and I'm applying a next line function to take the next string value of white spaces. I am initializing the graph over here, and then I'm taking the integer output as required and adding the I with the P of I, right? Remember, in the array, we always give P of I, right? We always give P of I. So here I'm giving P of I, and here I'm giving I, and I'm attaching I with the P of I, right? From I will go to P of I. Like from 1, I'll go to 2, 2, I'll go to 3, and 3, I'll go to 2 again. And then I'm running this function of finding the culprit. Now for every student, right? This is the student. Or if you wish, let me change the variable name as well. Now it's much better. Now for every student, where student ranges from 1 to n, I'm running the simulation. Now, here it is. I am passing the graph, I'm passing the starting node, and I'm passing the visited array. Now, if the node is already visited, right? If the node is marked, if it is true, then I simply print the node and end the recursive call, right? And end the recursive call. Otherwise, I'll mark the current node as true, the current student as true, and I'll check the neighbors, right? I'll keep checking the neighbors while running a recursive call. Here I was passing node, and here I am passing the neighbors. I'll keep on running the neighbors and check the code. And we'll keep on running. This particular function will take order of n time. And this particular function will take order of n time, giving it to order of n squared. Right? That is how it will work out. I'll post the code with you in the description down below. I'll give you the link. I'll be sharing these notes as well. So please don't forget to like, share, subscribe to the channel and hit the bell icon for more notifications and more such related content. Until then, see you soon. Bye.